Hello, welcome. My name is Kasozi. This is part 2 about a multi-band compressor. And this time we're going to look at how it is used direct on a vocal.
So I've called up a different project here. This one has got a limiter on the end of it here. C, which we didn't have on the other one. There are other settings here because I was kind of teaching. So my voice will have changed in this one. Anyway, now there's a vocal here. And on this, I want to demonstrate the multiband compressor again. I'm going to go in and dynamics, multiband or multipressors. Logic calls it. And I have my preset here, vocal demo. I already did a preset that fits the voice that I'm talking about here, but I'm just going to explain quickly why I did the settings I did to show that actually the multiband can be used on a single track. It doesn't have to be like groups and when you're mastering and stuff like that, even though it's designed mostly for those purposes. But here, I'm applying it direct on a single track, like a voice. Why would I do this here? It's because I want to see that I can be able to control the different ranges of frequency within a particular signal, especially one that is singing up and down in different registers, or is changing voice, like you're going into falsetto and back in a normal voice, and then you get a range of frequencies that are being presented and you can control them within the signal. Now imagine if the makeup gain parameter was a fader. Then I've got two of them to control loudness of specific frequency bands within a particular signal. Of course, this is what we'd do if we're dealing with like an EQ. If we are dealing with an EQ and we're doing this kind of vibe, whatever, we are controlling different bands because these are actually bands, like various bands here. And it's what we're doing. But the difference with the multiband compressor is not only that you're being able to control those frequencies, but you're controlling them according to how loud they're getting. If they're below the threshold, then they're not going to be touched. However, should they go beyond, above that threshold, then they're going to be contained. Whereas if I'm dealing with this, then that means that if I do a cut here, then all those frequencies there in the green have been basically cut away, regardless whether they were within a level that is acceptable or not. And remember, since the voice is going up and down, it's changing levels up and down. When it's down, those frequencies maybe wouldn't have been a problem. But then I've already cut them. Where the multiband is better is that it's able to cut specific frequencies, but it only cuts them at the points where they are going over the threshold. So in this case, let's have a listen to it when it's actually switched off, so we see what is going on here.
All right. In the morning, break of dawn, I wanna bask in the light.
Perhaps I should actually take the effects off.
All right. In the morning, break of dawn, I wanna bask in the light.
Yeah, you get the idea. And then once it's on,
all right. In the morning, break of dawn, I wanna bask in the light. And when the sunshine comes up.
so you can already hear that there's a certain clarity there because there are all these low frequencies that have been contained. And then with the upper frequencies, especially the really high ones, there's an opening in them. So there's a clarity that is there. Because even with the upper mids here, around 5K and stuff, the compressor is not pushing down the way it is in the lower frequencies. Anything that is below 770 hertz has been contained. Look at the ratio. I'm really compressing a little bit harder, a ratio of 7 to 1. And the threshold has been brought down to be able to catch a lot of stuff. But that doesn't mean that it will catch everything. So anything below that, it will not catch. But then, of course, there's much that is there. And if we come back again and look at the third band here, the ratio remains 2 to 1, the threshold is not too low, so there's not going to be much compressing going on. And then there's a minute 0.5 dB raised on the makeup gain. So that means there will be more clarity, not because I've raised too much gain here or anything, but I'm not compressing as hard. So this stuff, this side, is getting out of the way. The ugly stuff that was resonating in the boomy frequencies, the ones which were hanging around the 250 all the way to 500 area, are being reduced. And why did I do this whole thing here? Because already on this vocal, I'm hearing many things I don't like. I didn't need it to be like I do something special on the first half of it, on the first lower frequencies, then maybe from 100 I do some other thing. No, I needed to do like a blanket thing to deal with everything below 800. And that was the idea. Even though when you come into multiband, you're trying to be a little bit more precise to zero in on things. But the zeroing in here is more to deal with all those frequencies below 800 to control how much of them are coming through in this particular signal. And on the other hand, the other side, we leave the top mids. We don't touch them too much so that everything that has gotten out of the way gives them time to shine. And then I just prick it up a bit with 0.5 dB. Then we have here, I won't call them low mids, and the second band. These are still mids. Maybe I'll call them, just mids. We're in the mid-mids. From roughly 800 or whatever, 770 hertz, up to 2.8 kilohertz. This area here is also being compressed quite some, at a ratio of 3.6 to 1, but the attack doesn't come in too soon, so it doesn't react as fast as it does on the lower end. So again, I was finding that the vocal here was kind of bringing out tones that were not cool. And that was just because, I'm recording on this same mic that I'm speaking with, and I'm just, in a room that is meant for doing vocals. So there were all kinds of tones that are coming through that are not nice. And this was one way to contain some of those things. Of course, it can be done with EQ, but I already explained why it might be preferable to do it with this. And I have to say, I stole this kind of technique from Tony Maserati, a famous mix engineer, really, really good at what he does. We have to steal from the best if we want to do better. Because with this, we also have an expander down here. I thought that what I could do with the highs was to expand out those dynamics so that it can shine a little bit more at the top end. And if you don't know about an expander, check out the video about the expander and you can have a look at that. What we do is to get the threshold of the expander as low as possible. You can see if I move it, this here. If I move this again, you can see that is moving. So I get it low enough so that it takes in whatever is happening, and everything that is above this threshold is going to be pushed higher still. That's what the expander is going to do. It's going to push it higher. How much is going to push it is this ratio here, which I've put here. So it will multiply it by basically this number, and it will make it louder. This adds high frequency information, or brings out the high frequency information and brings it to light. So let's have a listen to it again. If I just kind of solo this, then we just hear the high frequencies. Maybe it might be better when we're not listening to everything else, especially this music.
All right. In the morning, break of dawn, I wanna bust.
Yeah. And if I take this off without the processing.
All right. In the morning, break of dawn, I wanna bust in the light.
And then let's have a listen to it with the processing on.
All right. In the morning, break of dawn, I wanna bust in the light.
Yeah, it's lighter on its feet, so to speak. It's elevated a little bit, and that makes it cut through better in the mix. Yes, I could achieve this with EQ. In a sense, using a multiband compressor for EQ is not that ridiculous because already there are plugins now that are actually doing this. So if I go and look for Isotopes Dynamics EQ. This one comes up. So you see, it has several bands, 1, 2, 3, 4, 5, 6. And the way it works is that every band that is there, it's really EQ, as you can see. Yeah. But each of these bands actually has compression going on. You can see there's a threshold here, there's attack, there's release. Yeah. So it's not that ridiculous that I would be using a multi-band compressor in the place of EQ if I don't have something like this, for example. When it moves,
Banagi, all right. In the morning,
you can see that white line pushing down. That's basically the reduction, the compressor pushing down also. So it's not just cutting out all those frequencies anyhow. It kind of pushes down when it's necessary. Yeah. So using this guy here is not that ridiculous an idea. You should try it for these purposes or experiment with it. Of course, it's not the best. If you have other multiband compressors, maybe third-party ones that you can use to do this that are a little bit more elaborate, then great. If you happen to find like that you have a dynamic EQ, then that will be even better. But in the absence of that, then this can be employed. And at the same time, it prepares you for whenever you are able to acquire a multiband dynamic EQ, like the one provided by Isotope, the guys who make ozone. So the principles that we've covered here are kind of similar to what you would actually employ here, maybe in a different way, because all the controls are different and stuff, but it won't be difficult for you to understand what's going on there. So let's listen to this in the context of the music.
Banagi, all right. In the morning, break of dawn.
That is very different from this.
Banagi, all right. In the morning, break of dawn.
Yeah, then this.
Banagi, all right. In the morning, break of dawn. I wanna bask in the light, and when the sunshine comes up, I wanna break into song.
You get the idea? Alrighty then, take care now. Goodbye.